Okay, let's start. So today we're going to go through the two exercise. So unit 22 exercise first, and then unit 29 exercise. So the first one we learned in unit 22. So there are 4 things we need to do if we're given an example of electrolysis. So the first step, we just need to list out all the ions in the electrolyte. And then second, we need to check whether there are high concentration of halide ion in the electrolyte. And third, we need to consider is an inert electrode used, for example, carbon, graphite, platinum, okay? Or for the, especially for the anode, is the copper or silver electrode used, okay? That's a third factor. And if none of the above factor, the second and the third factors didn't exist, then we just go to the fourth point. Then we compare the strength of oxidizing and reducing ability and work out which ion would preferentially discharge at both electrode. Okay, so that's just a quick recap of unit 22. And I have marked all your exercise, and let's go through some of the questions together. Can you all see the screen of my iPad? Okay, so first one, we got question 5. For this one, part A, you need to fill in the first, the battery part. So which one should be connected to the positive side of the battery and which side should be the negative one. Okay, and then you need to label what electrolyte you choose for this experiment, and then you need to label this part. Okay, so the answer given to you, you should label the silver rod. Okay, better use the silver rod because it can replace the use of silver ion in the electrolyte. However, as I have explained for the MC question, you can also use the inert electrode. Okay, if you don't understand this part, you can watch the video about the MC questions. Okay, and then this part should be connected to the positive side of the battery. And the object that you want to get it electroplated should be connected to the negative side of the battery. So you need to at least label 3 parts: the battery, the rod, and also the electrolyte. That's for part A. And then for part B, suggest a method besides painting or electroplating that can prevent underground ion-made pipelines from rusting. Okay, so here it suggests 2 best ways to prevent underground pipe from rusting. So first, you can connect a more reactive metal to the surface of the pipelines. That's sacrificial protection. And then the second one is you can connect it to the negative electrode. So that's the cathodic protection. So you need to refer to unit 13 of grade 10 notes. Okay. So any question for this one? Question 5. Should I move on? Okay, so next one. Okay, so here the electrolyte is a solution of 1 molar potassium sulfate. Okay, so 1 molar means it's not concentrated. Okay, so pretty dilute solution. And for this one, remember the first step we need to do is list out all the ions. So we have potassium ion, we have hydrogen ion, we also have hydroxyl ion and sulfate ion. Okay, and then the second one, we need to check whether it has concentrated halide ion. So in this example, no, we don't have any chloride, bromide, or iodide. Okay, so then we skip that part. And for this one, you can see both of the electrode of inner electrode platinum, it would not involved in the reaction. Okay, then we move on to the fourth step. We just compare their reducing and oxidizing ability. Okay, so you can refer to case 1 of your notes, Unit 22 notes. So because electrode A is connected to the positive side, so negative ion, N9, should be attracted to here. So hydroxide and sulfur ion should be attracted to A. And potassium ion, hydrogen ion will be attracted to B. And then if we compare the strength of each pair, then we should know that it will be the hydrogen ion and also hydroxide ion that get preferentially discharged. At electrode A, it should be hydroxide ion that get discharged, and then at electrode B, it should be hydrogen ion that get discharged. So for part A, it asks you to write the observation. So at A, you should write that hydroxide ion are preferentially discharged to give a colorless gas. Right? Remember, for observation, we don't mention what substance is formed because we haven't tested for it. Okay, so normally we don't mention the name. Okay, and then for B, okay, so again, you need to first mention hydrogen ions are preferentially discharged to give the colorless gas. And then remember the question here also stated that it has a phenolphthalein indicators in it. Okay, so for phenolphthalein, you need to remember in acidic solution, it's colorless. But in alkaline solution, it will show a pink color. Okay, so now I got question, what is hydroxide ion but not hydrogen ion? What? You mean at which electrode? At B? A1, electrode A. Okay, because it's connected to the positive side. Yes, you can unmute yourself or type in the chat part.
Why?
Yes, I can hear you.
You can hear me? Okay, nice. 我用中文好得唔得啊？嗰個叫啲 OH ion 咧會嗰個叫咩attract to 嗰個 positive electron 啦，in this case 嗰個 anion 啊嘛，係咪？即係 platinum electrode A 啦，OH minus ion。咁理論上嗰度係咪個 phenolphthalein color 係咪應該嗰個叫粉紅色啊？係 pink。
Okay, but those hydroxide ion when attracted to A is used up quickly, so it won't be able to give the color.
即係唔會有顏色嘅，係 instantly turns to
Yes.
O2 gas 嘅。
Yeah.
So, okay, 即係 okay, thank you.
And for A1, let me check. Yes, A1 because it's positive, so it attracts anion, so it would be hydroxide that get discharged from oxygen. Is that okay? And if we run to A2, the second part, because hydrogen ion is used here, so it left with excess of hydroxide ion. So that means the solution near electrode B, okay, become alkaline because it got more hydroxide ion. Okay, and then it will show a pink color. So you need to write 2 observations for electrode B. Okay, and then the next one, write the equation for the overall reaction. So at electrode A, that's the hydroxide turning to oxygen. Electrode B, that's hydrogen ion turn into hydrogen gas. And then if you combine the 2 equations, you will get this one. Okay, and for C, explain whether there are any changes. So a lot of you, I have seen that you only stated what's the expected observation. But here, it actually asks you, is there any changes in the expected observation? So you need to compare your answer for this situation with the one that you wrote for A1 and A2, okay? So first of all, you need to state, yes, there is a change, or no, there's no change. Okay, so for this case, there should be no change. Take a look at A first. Okay, if we change it to sulfuric acid, again, for the anions we have, it's still sulfate ion and hydroxide ion. So at electrode A, still hydroxide ion get consumed or discharged. Okay, so there's no change. You can just see a colorless gas. But for B, okay, now we have changed the potassium sulfate to sulfuric acid, so no more potassium ion, but just hydrogen ion. So the hydrogen ion concentration increased significantly. Okay, so last time we said for after hydroxide ion has been discharged to form hydrogen gas, it leaves the solution. But this case, because we have excess of hydrogen ion, so the color, you can say it would become less obvious, okay, or less pinky, or you can even say it remains colorless. So that's the electrode B. So 2 ways to answer it. Okay. No color change, or much less obvious, remains colorless. Okay, any question for this part? Well, you would say no change for the gas produced part, but still the color change disappeared. So it's not no change for the color of the solution compared to your answer in A2. So for example, here, the model answer, if you put no change for the first sentence, that's okay, but it's not suitable to put it in the second sentence to mention the color of the solution part. Okay, can we move on? Okay, next one, question 8. So this experimental setup tells you that electrolysis of a molten substance, okay, SrBr2. So here we only have 2 kinds of ions. So it should be Sr and Br. Okay, and then state the observation at carbon electrode X. So X is the positive electrode, so it should be the negative ion attracted to here. So bromine ion attracted to here, and it would be discharged to form bromine. And normally, bromine is a liquid at room temperature. But remember, we are doing it under heating. Okay, so the bromine formed at this part will actually turn into gas readily. And actually at room temperature, bromine liquid turn into gas readily as well. So it will form a reddish brown gas at electrode X. Okay, so two substance you need to remember, they are liquid at room temperature. So that's mercury and bromine. And bromine liquid, it evaporates readily to form the reddish brown gas. And this reddish brown gas is actually toxic. And then write the half equation for the change that occurs at carbon electrode Y. So it should be Sr2 plus that get discharged at electrode Y. So it will gain electron. So B, okay, what it should be performed in a fume cupboard. So as I said, bromine gas is toxic. And then C, okay, deduce in terms of change in oxidation number. So you need to work out or show me the way that you work out which one is the oxidizing agent. If only brown color is observed for A1, I think that answer is incomplete. It's yeah, it's not wrong, but it's incomplete. I don't think you can get full marks for that answer. Okay, and for if I move back to C1, so changing in oxidation state for Mn manganese is from +4 to +3. So Mn2O2 is the oxidizing agent. And then you need to write the half equation accordingly. So if you forget how to write half equation, do remind yourself. So you separate the ionic compound that's in aqueous solution, and then you cancel out the spectator ions. And yeah. Okay, so can we move on? Any more question about this? If that's okay, I'm going to start question 9. Okay, so for question 9, okay, let's take a look at the setup. So we have concentrated potassium iodide, okay, and then we also have universal indicators in it. So again, let's write out the ions that we can find in the setup. So we have potassium ion, we have hydrogen ion, we have iodide ion, and we have hydroxide ion. And the second factor, this time because it's concentrated potassium iodide, so iodine ion actually got a very high concentration. Okay, so at the positive electrode, it should be the iodide that get preferentially discharged. Okay, and also at the positive electrode, it should be potassium that get it should be hydrogen ion that get preferentially discharged. Okay, so for the first part A, expected observation at electrode A. Electrode A is connected to the positive pole of the battery, so it should be iodide that get preferentially discharged. So at least you can get marks for this part. Okay, and for the color, because we haven't learned group 7 unit, okay, we will have a unit discuss the property of group 7. So after learning that part, you will be able to work out the color. So for now, just write the answer, okay? And then part B, the solution near carbon electrode B gradually turned blue. Okay, so for universal indicator, okay, yeah, before we move on, just finish our question first.
喂，聽唔聽到？嗰個叫 Line A 嗰度咧，嗰個係 iodine 咩嚟㗎？即係我寫 iodine solid，你話我錯，咁係咩嚟㗎？I2
Gas.
It's a gas. OK，好唔該。
Around the electrodes, so would be here, roughly this part, near the electrodes. Okay, and then for part B, yes, universal indicator. You need to have a rough idea how universal indicator gonna change color. So it would change from red, which is very acidic or strongly acidic, to green, pretty neutral, and then to blue, that's alkaline. And if it's around 14, pH 14, then it would turn purple. So here it turned to blue. So that states that it should be an alkaline solution near electrode B. Okay, so why it shows an alkaline solution near electrode B? So here you need to write that hydrogen is discharged to produce hydrogen gas. Hence, it will have higher concentration of hydroxide near electrode B. Hence, it will give a blue color because it's alkaline. Okay. And then, will there be any change in observation if carbon electrode is replaced by a copper electrode? Okay, so first let's work out what will happen if it changes to a copper electrode. So electrode B is the negative electrode. So that's a cathode. So cathode should gain electron and undergo reduction. Okay, so let's imagine what will happen if copper gains electron. It will become copper minus. And from what we have learned so far, we've never seen anything with copper minus, right? So actually copper will not be able to gain electron. Okay, so it should be no change. Okay, if you choose to say no, then you will say because copper will not gain electron, it's still hydrogen ion that get discharged. But if you choose to say yes, you can also provide a reasonable answer is that the electrical conductivity gonna be different. Okay, so the rate of turning blue gonna be different. Okay, any question for this one? Okay, if no more question, then I move on. Any more? Yeah, one more. Okay, so for this one, I think most of you did pretty well compared to the previous question. So for the first one, why oil, oops. Okay. Yep, if I have to end this session after 10 minutes, I'll send you another code. Okay. Yes, go back to B2. There's no need for you to rush to write all the answers. I will post it again on Google Classroom for you to take a look. Next one. Okay, so the first one, what orders on the object should be removed? Okay, so this part specifically mentioned that you should have a specific description. So if you only state the result of the electroplating will be pulled, or the copper won't be so easily electroplated on the object, then that will not give you the mark. Okay, so you can say it hinders the conduction of electricity, hinders the plating of copper on the object, okay, because it got an uneven surface. So the copper will not be able to stick on the object firmly. Okay, that's for A. And then copper 2 sulfate is an electrolyte. What is meant by the term electrolyte? So a lot of you have mentioned electrolyte is can let ions to move so it completes the circuit. But you didn't mention where all the ions come from. Okay, so here you need to mention that those ions are from the electrolyte. It provides the mobile ions to complete the circuit. Okay. And then list all the ions existing in the solution. No problem for this one. And why copper 2 ions are preferentially discharged? Because of the position on the electrochemical series. Or you say it is a stronger oxidizing agent than hydrogen ion. Okay, and then write the half equation. Easy one. State the observable change, if any, in the solution. Okay, so for this one, some of you made a mistake. So you have noticed that the copper ion in the solution would turn into copper and stay on the object. So in principle, you would guess that the color of the electrolyte will become lighter. However, in this experiment, it uses copper as an anode, so it will release the copper 2 ion back into the electrolyte. So actually, the rate of consuming copper 2 ion in the electrolyte is the same as the rate of producing copper 2 ion to the electrolyte. So it should be no change. Okay. Any more question about this part? Okay. How about we start a new meeting so that I don't need to stop in the middle of unit 29. Yes?
嗰個叫你話因為呢個 copper electron 啊嘛，個 copper electron 唔係會自然消失嘅咩？
What do you mean disappear?
disappear 即係 dissolve 啊，係咪 dissolve 咧？
Yeah, it forms Cu2, but it says if any in the solution.
哦 ，OK，
right?
睇錯問題啫咁，sorry，咁冇嘢啦，好啦。
Yep.
唔該。
F the copper electron. Yeah, the same question. Yep. Okay, so I'll stop here. Maybe I start a new meeting so that we can go through 29 without any interruption. Okay.